Okay, so welcome back. Now we're going to do an example of using logarithmic differentiation to take the derivative of a function that we normally wouldn't be able to take the derivative of. So the first thing is, notice that we've got this polynomial raised to this function here. So we've got a function raised to a function. So the first thing we're going to do is we're going to take the derivative of both, or excuse me, the natural log of both sides. So we're going to take the natural log of both sides. Why? Because we want to get this exponent out of here. So the natural log of y is equal to tangent x times the natural log of 2x squared plus 1. Okay, so what I did was I used the property of logs, took the log of this side, then I used the property of logs to bring this down. Now I'm going to use the property of logs. Well, actually, no, I can't use the property of logs because this is sum. So we're done. So this is the best I can do right now. So now we're going to differentiate both sides. So if I differentiate this side, what do I get? I get 1 over y dy dx. So again, implicit differentiation. And now what happens here? Well, this is going to be, a product rule. So this is going to be the derivative of the first times the second. So the derivative of tangent is secant squared x times the second, which is natural log of 2x to the fourth plus 1, plus the first times the derivative of the second. And of course, this is what is this? It's a natural log, so it's going to be 1 over this. So it's going to be 1 over 2x to the fourth plus 1 times the derivative of the inside, which is going to be 8x to the third. Okay? And now I'm going to multiply everything by y. So I get dy dx equals secant squared x times the natural log of 2x to the fourth plus 1 plus, now this one is going to be, let's see how I'll write this. So this will be tangent x times 8x cubed over 2x to the fourth plus 1. And of course, I'm multiplying everything by y, so I'm going to get a y here. So I get a y here, and I get a y here. Okay? So now I'm going to replace y with the original function, which is this. But you know what I'm going to do? I'm going to factor out the y because there's nothing I can do with this, and I have a common factor of y, so might as well factor this out now. Okay, so I'm going to write this as that. And so I'm going to get dy dx is equal to 2x to the fourth plus 1 raised to the tangent x power times secant squared x times the natural log of 2x to the fourth plus 1 plus, do I bring that tangent in? No, I'll just leave it out. So this will be tangent x times 8x cubed over 2x to the fourth power plus 1. And that is our final answer. Now, complicated looking answer, but again, that is the answer. Okay? And how did we get there? By using logarithmic differentiation. Okay, so now we'll do another one, and again, practice these.